Welcome to the Mahatma Gandhi Institute of Technical Education and Research Center. In 2004, a national level institute MGITER has been started in the field of engineering and technology as per guidelines of All India Council for Technical Education AICTE New Delhi. MGITER is approved by AICTE New Delhi, Gujarat State and affiliated to Gujarat Technological University Ahmedabad, which is also known as GTU. Our goal is to be an institute of generative ideas so that we remain relevant to our society. The MGITER has always been an organization on move with continuous effort on improving its processes and to maintain its relevance to the Indian science scenario, with adding new programs in its programmatic portfolio. We strongly believe in overall development of students, so for that we provide them a different platform like state level tech fest, project fair, different sports activity, which helps students to teach teamwork and problem solving skills to get physical health benefits, boost self esteem, and reduce pressure and stress for prove their skills in distinct area. Welcome to the virtual class of electrical measurements and measuring instruments. Myself, Professor Gaurang Patel from Mahatma Gandhi Institute of Technical Education and Research Center, NAVSARI. Today we are going to discuss about the chapter 1, that is the concept of measurement, and the topic of today, that is static characteristic, accuracy, precision, sensitivity, linearity, range, and reproducibility. Okay, so those are the topic that is I will cover in today's lecture session. Those all terms are very important according to the this subject, that is electrical measurement and measuring instruments. Okay, so we will begin with the static characteristics. So what are the things which is including in that static characteristic, that we will see one by one. Okay, so you can see the some of the definition, that is static characteristics of instrument. The static characteristics are defined for the instruments which measure quantities which do not vary with time. Okay, the quantity which is do not vary with time, that means it doesn't have any make difference with the time is going to be past. Okay, and you can define the accuracy, that is the degree of closeness with which the instrument reading approach the ट्रू वैल्यू ऑफ द मेजर्ड वेरिएबल. दैट मीन्स हम अगर किसी इंस्ट्रूमेंट्स की वैल्यू को मेज़र करते हैं तो वो एग्जैक्टली उस जो वैल्यू हम मेज़र कर रहे हैं उनके कितने करीब वैल्यू हमें मिलती है, दैट इज़ द क्लोजनेस ऑफ द मेजर्ड वेरिएबल, दैट इज़ नॉन एज द accuracy. Okay, so and it is also defined as the maximum amount of by with the result of differs from the true values. Okay, so these two things we have to keep in mind, that when you are define the accuracy. Okay, and that is the equation of accuracy that is given over here, that it is says that the accuracy is equal to scale reading minus true value divided by scale reading. Okay, so whatever the reading you will get onto the scale minus true value divided by scale reading, you will get the percentage of accuracy. And also you can use this equation, that is accuracy is equal to scale reading minus true value divided by full scale reading into 100. So both of equations will help you to find the accuracy of particular instruments. Okay, so I hope you understood what is the definition of accuracy and how you can work with this definition. Okay, so that's how you can find the accuracy with this uh, equation. How you can find this equation, how this equation is going to be work, I will show you with the help of this example. So over here you can see this example is given over here. So what example states that one ammeter is given over here, that is an ammeter of range 0 to 20 ampere, and which is indicates 5.2 ampere when the value of current is a 5 ampere. Okay, so now when you apply the equation, that is accuracy is equal to what? The accuracy that we taking as an scale reading. Okay, so the scale reading, that means here that is given an emitter of range 0 to 20 ampere indicates 5.2 ampere. So 5.2 ampere is your scale reading. Okay, and this minus 5 stands for what? That is the true value. So scale reading minus true value divided by scale reading. So it is 5.2 minus 5 divided by 5.2. So you will get the 3.85 percentage of accuracy. So you can say that this instrument having the accuracy of 3.85%. Okay, and most probably in measuring instruments there are given there is a plus or minus 5% accuracy or error can be tolerated. So that is, you can say that this is the accuracy that how we can find. And it is one more example is taken over here, जो हमने दूसरा भी एक इक्वेशन लिया हुआ है यहाँ पे, दैट इज एक्यूरेसी इज इक्वल टू स्केल रीडिंग माइनस ट्रू वैल्यू डिवाइडेड बाय फुल स्केल रीडिंग. सो स्केल रीडिंग इज 5.2, दैट इज योर ट्रू वैल्यू, दैट इज अ 5 एम्पियर, बिकॉज 5 एम्पियर का हमने एमीटर लिया हुआ है. ओके, सो ओवर हियर that is the percentage of 1%. Okay, that is a full scale deflection. So that's how you can find out the accuracy of particular instrument. Okay, so further we will see that is accuracy can be expressed in number of ways. There is one that is intrinsic accuracy, and second one that is the point accuracy. So what is intrinsic accuracy? Here is the definition is given. If you read the definition, you can see it is the accuracy stated by the manufacturer under certain conditions. So manufacturer will give you a certain condition. According to that condition, you have to measure the accuracy of that particular instrument. And also it says that it is the accuracy of instrument when calibrated in laboratory in absence of vibration, ambient temperatures changes, etc. So there is a standard condition is going to be provided in laboratory, and then its accuracy is going to be measured. Okay, so that's how you can achieve this instrument must be carefully cited, maintained and standardized. And another definition, that is the point accuracy. This point accuracy we can measure, this is the accuracy of an instrument at one point on its scale only and does not give any information on generally accuracy of an instrument. Okay, so the general accuracy may be given by a point accuracy throughout its range. Okay, so over here we can measure define, that is intrinsic accuracy or the point accuracy. Then after we will see what is the precision and how we can say that instrument will give you a precise value. Okay, so if you would like to define the precision, that is if the same value of the measured variables is measured many times with good number of significant digits and all the results agree very closely. Okay, then the instrument is said to have a high degree of precision. That means if we will take one instrument, अगर हमने एक instrument लिया, उसको उससे एक certain value, for example कोई किलोग्राम, कोई मशीन, कोई वेट मेज़र करने वाला मशीन हम लेते हैं, then when we measure the weight for the particular, for example 1 kg weight we will measure and it will give some basic reading. So number of readings we are taking after one by one and we noted down that reading and make the average of it, and that's how the precision can be taken place. Okay, so same example is given over here. Once again we will repeat the definition of precision. So and this is the definition so many times asked in examination as well. Okay, so take care of it. Precision, if the same value of the measured variable is measured, what is a statement says, if the same value of the measured variable is measured many times, okay, with good number of significant digits and all the results agree very closely, then the instrument is said to have higher degree of precision. Okay, So here one example is taking over here. You can see there is a consider a set of reading taken by a voltmeter to read a non voltage of 1.45 volt, and the readings are taking over here. So 7 readings has been taken place, 7 readings हमने यहाँ पे लिया हुआ है. तो इस तरह से हम इसका मीन रीडिंग फाइंड कर सकते हैं. ओके, जितने टाइम्स हम रीडिंग ले रहे हैं, हाउ द नंबर ऑफ टाइम्स दैट वी टेकिंग द रीडिंग्स, दैट यू हैव टू divided with that numbers and you will find the mean reading of that is 1.44 volt. Then you have to apply that maximum deviation. Okay, so the maximum deviation, that means जो सबसे हायर वैल्यू का रीडिंग हमें मिला है वो हमें लेना है, दैट इज द मैक्सिमम डेविएशन, दैट इज 1.47, एंड सब्सट्रैक्ट द वैल्यू ऑफ मीन रीडिंग एंड यू विल गेट दिस 0.03 वैल्यू. Okay, so that's how you can find out the reading, that is 0.03 volt, that is the maximum deviation. Then after you can find out the percentage of precision. Okay, so percentage of precision you can find out with over here, that is maximum deviation, just a moment. Okay, maximum deviation divided by true value. So over here maximum deviation, that is 0.03 volt, and the true value, that is your 1.45 into 100, so that is 2.07 percentage of precision of that particular machine, you can say like that. Okay, so if in examination, if you would if any examples related it of precision, to measure the precision of that particular value, so you can easily measure through this equation. Okay, first you have to find the mean reading, then you will go for the maximum deviation, and then you with the help of those two answers you can find out the percentage of precision. Okay, I hope this definition and how it will be calculated, that you will understand well. And you can also give the precision with the help of this equation as well, that is precision is equal to 1 minus xn divided by xn. So over here xn stands for the value of nth measurement, and this bar xn is stands for the average of set of n measurements. Okay, so this precision of measurement is a quantitative or numerical indication of the closeness with which a repeated set of measurements of the same variable agree with the average set of measurements. Okay, so that's exactly what given, that we have seen in that example, that set of reading are taken place and how much number of readings we taken, and that divided with that numbers, and you will able to find out the precision. Okay, after the getting idea of to measure precision, we will see some of the characteristic of it and some of the definition regarding that. So that is, the precision comprises of two things, that is conformity and significant figures. So in conformity you can consider, that is if you consider a resistor having a true value of that particular ohm, that which is being measured by an ohm meter. Okay, now the meter is consistently measuring the true value of the resistor, but the reader can read consistently a value of 4.9 mega ohm due to non-availability of proper scale. So it happens so many times in the instrument, because that it will shows that particular value of ohm, but in laboratory there is no availability of such of instrument, so that could be the misjudgment or wrong reading can be taken place. So that's why the precision is very necessary. Okay, and one more example you can see is that the conformity is necessary, okay, but not sufficient condition for precision. Similarly, precision is necessary but not the sufficient condition for accuracy. So from that also you can see what is the precision and what is the accuracy and what is the difference between precision and accuracy, that also you can derive from those definitions. So another thing you can say that some of the significant figures, because significant figures are very necessary, as we shown that if you take only a reading for 1 or 2 times, so it may happen that the wrong results may be occur. So that's why you have to take a number of time, that results should be taking a number of time, and then you have to decide the that precise value. Okay, and once you know what is the precise value, then you can finally go for the final measurement value. Then after we will see that is the difference between accuracy and precision. So many times that is this term is misunderstood, that is the accuracy and precision is the same thing, but it is not necessary. There is some particular differences over here in technical terms, that is the what is accuracy and what is the precision. We can I just bifurcate those points which is related, and we can be that can be differentiate between the accuracy and precision. The first point, that is precision is necessary but not sufficient condition for accuracy. That's what we discussed. And accuracy of a reading not essentially guaranteed by its precision. That means that precise value, that it is not necessary that is accuracy is being confirmed, and with the accuracy it is not being confirmed that this is a precise value. Okay, to explain above statement, if you consider, there are one example is given over here. Okay, one example is given over here of the 2 voltmeters. That 2 voltmeters are made with the same rating, same company, but till if you make some changes of it, for example one resistor is connected in series, that definitely it will going to be a different value. That what over here it is explained. If series resistance of one of the meters changes considerably, that voltmeter will show high error, and hence it will be less accurate than the other. Okay, if you connect a series resistor in one of the voltmeter, so it will be give you an erroneous result. So from that we can say that high degree of precision is however no indication that the value of measured variables accurately determined, or it is accurate calibration that makes accurate measurement possible. Okay, so that's how you can differentiate this differentiate between the precision and accuracy. Okay, then after we will see over here, that is the reproducibility. Okay, so when you define the reproducibility, that means when an instrument can produce a result each and every time, an accurate result it can be produced. So specifically it is given over here, that is it is the degree of closeness with which same value of variable can be measured at different times. So same value of variable can be measured with the different times. Okay, and it may be specified in terms of units for a given period of time. And also you can say that perfect reproducibility means instrument has no drift. Okay, so that's how the reproducibility can be defined. Okay, then after reproducibility we will going to understood one more term, that is range, or you can say it is range or span. So most probably we understood those terms by its name itself, that is range or span, but technically how it will be defined we will see over here. That is the scale or range of an instrument is defined as the difference between the largest and the smallest reading of the instrument. That means one एक अगर एक कोई इंस्ट्रूमेंट है जो 0 to 300 वोल्ट के लिए डिज़ाइन किया गया है, तो उसका मिनिमम वोल्ट, मिनिमम जो रीडिंग वो कैलिबर है लेने के लिए वो, और मैक्सिमम रीडिंग जो वो ले सकता है वो, उसके बीच का जो डिफरेंस है उसको हम उस इंस्ट्रूमेंट की रेंज और अदरवाइज उसकी स्पान कहेंगे. ओके, सो इट इज सेज दैट इफ द लार्जेस्ट रीडिंग दैट कैन बी रीड बाय एन इंस्ट्रूमेंट इज x max, that is the maximum value that can be read by that instrument, and the smallest reading of that can be used by the instrument is x minimum, that is the minimum reading of capacity of that particular instrument. So then we say that the range of the instrument is between x minimum and x maximum, or we say that it is the value, or it is the span of x minimum, x maximum to x minimum. Okay, for example a voltmeter of range 0 to 300 volt can be measured up to 300 volts. So that's how the particular range or span can be defined of that particular instrument. Okay, so I hope in today's lecture whatever the points we are going to be covered, that you understood very well. Okay, So finally in this lecture we will take up till that, and another points we will be covered in the next lecture. So usually I give you each and every time one message, that is, please remember turn off the light whenever there is no necessity or no necessary to use of light. Please remember to turn off the switch. Okay, so because saving energy is saving life. Okay, thank you very much.